Honored algebra students, and here's part 2 of your video. And this will go a little quicker because we're more familiar with it. We just prepared for a quiz on it not too long ago. We are solving systems by substitution, elimination, graphing. Of course, we will also talk about parallel and perpendicular lines, and we will talk about solving systems of inequalities. Tell you what, let's start with solving systems of inequalities. Let's do that first. All right, so this first one is in standard form. I think I'm going to find the x-intercept right away, right off the top of my head. It's 4. 1, 2, 3, 4. Ha, ha, ha. There is the x-intercept. The y-intercept is just as easy to find, and that's going to be 2. 1, 2. You should know how I'm doing, but at this point, I wonder. Some of you claim you don't know how to graph, and yet you don't come in for help. Some of you, I haven't seen in for help in months. No excuses. Get your butt in for help. Okay, now, my slope, by the way, is a negative 1 over 2, right? So if I wanted to get another point, I could go 1, 1, 2 like that. Or from this point, I could have gone down 1 and right 2. Or from this y-intercept, I could have gone down 1 and right 2. And look, all of them are on the same line. Now, it's not an equation, so 1 back 2. It's going to be a broken line looking like that. All right, there we go. Zoop. Okay, I'll make it a little thinner. There we go. My line gets too fat. I can't tell what's going on with it, so I like my lines thin. But that's okay. Only talking about lines. All right, here we go. Now I got to decide where to shade. Well, I got my highlighter out a little too soon. I'm going to use the test point of the origin, because the line does not go through the origin. 0 plus 0 is less than 4. That is absolutely true. So I will shade towards the origin. That is wonderful. There we go. Sound effects help me shade. Woohoo. All right. Now, the other equation is in standard form. It's not too far from slope-intercept form, but if I try to convert it to slope-intercept form, I'm going to divide by a negative, which is going to flip my inequality. So I think I'm going to leave it in standard form. And I know that I'm going to get an x-intercept of 2. And my y-intercept, I believe, is going to be negative 6. 1, 2, 3, 4, 5, 6. And looking at that, some of you might go, wait a minute, am I going to have to flip that inequality when I divide? If you don't know, don't do it. Go for the slope. The slope is going to be 3 over 1, right? So watch this. I'll go down 1, 2, 3, back 1. 1, 2, 3, back 1. And notice I didn't flip the inequality when I figured out my y-intercept. So if you're confused, figure out a different way to think about it. All right, get this line in here. It is a broken line because it's not equal to. All right, let's make him a little thinner. Boom. Okay, and we'll do 0 minus 0 is greater than 6. Is 0 minus 0 greater than 6? Absolutely not. 0 is not greater than 6. So let me get a blue highlighter out here, kind of a turquoise. Yep, that's the color I want. And I'll shade the other side of the line. There we go. And you see my solution is the green region. It's a triangular region because it goes forever, right? Okay, there you go. Goes kind of like that. I'm not sure why I have some green over there, up there. Just ignore that. It's this green right here. Okay, they're solving a system of inequality. Should be easy for you to do by now. All right, let's see here. I'm gonna solve some systems of equations. Got to do one by elimination, one by graphing, one by substitution. tell you what, it might be smartest to pick the graphing one first because some of them aren't so easy to graph. And as I look at this, I think that this is going to be the one I want to graph. I think so, because I could get that to standard form pretty easily. I could, this is almost in standard form as well, or I could get it in slope-intercept form. I think I'm going to graph this one. In fact, I'm going to manipulate this first equation and make it read x minus 2y equals negative 7. How did I do that? I subtracted 2y. Now it's in standard form, and I know the x-intercept is going to be negative 7, 0. The slope is going to be 1/2, and that's enough information to graph. Now, to graph this one, I think I'll add 3x to each side, and I'll get y equals 3x minus 9. And there I have the y-intercept of 0, negative 9. And I have a slope of 3 over 1. That's ready to go. Why don't I just go ahead and graph it? Just go ahead and graph it, Mr. Lawrence. Do it! Quit talking about it. All right, so let's see here. I have a x-intercept and a slope, x-intercept of negative 7 and a slope of 1/2. So an x-intercept of negative 7, 1, 2, 3, 4, 5, 6, 7. And, oh, I can't remember. Is it negative 1/2? No, it is positive 1/2. So it's going to do this. Joop, 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 joop. And remember, I just like to do lots of points. Joop, because maybe I can find out where it crosses. All right. The second equation has a y-intercept of negative 9. A y-intercept of negative 9, which is down here, and a slope of 3. So 1, 2, 3, cha-cha-cha. 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 There we go. I found the place they cross. Now I'm just going to graph my two lines. Gonna graph my two lines. Gonna do it real fine. There we go. Hey, I'm a poet and I didn't even know it. Yeah, I know. I've told that joke like 85 times, but it still makes me laugh. Anyway, here we go. I'm gonna go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So the solution to this set is the 0.56. Oh no, I forgot my arrowheads. Oh dear, I don't want Andrew Ozanich to yell at me. All right, here we go. Let's slide down here. Now I still have to solve one of these by substitution and one by elimination. This one doesn't look friendly either way. This one looks like a good substitution one because the x is almost alone. I'm going to do substitution on this one. I'll get x to read 6y minus 11. Then I'll write 2 times the quantity of 6y minus 11 plus 5y, and that'll equal 12. 12y minus 22, distributing of course, plus 5y equals 12. And then I will combine like terms, get 17y, and that will equal 34. So y is going to equal 2. Now I will use this equation here to say that x is going to equal 6 times 2 minus 11, which I believe x will equal 1. So these lines cross at the point 1, 2. Now, by the way, these two systems are consistent systems. Why are they consistent? Because they have a solution. Okay. Furthermore, they are independent systems because they only have one solution. The idea of independent means stand alone or by myself, right? America, we had the Declaration of Independence. We told England we don't want to be ruled by you anymore. We want to be independent. We want to stand alone. So independent means one or by ourselves or standing alone. These are consistent systems because they have a solution, and they're independent because they only have one solution. Had they had more than one solution, like all real numbers intersecting everywhere, they would have been called dependent systems. Okay? It would be the same line graphed on top of itself. If two lines are parallel, they do not intersect, therefore they have no solution, and those are called inconsistent systems. Inconsistent. because there's no solution to it. All right, so let's move on to problem B. Now, some of you have adapted this shortcut where you just multiply one coefficient by the other equation and vice versa. And that's not always the best way. For example, if I look at 6 and 9 here, the least common multiple of 6 and 9 is 18. How do I know? Count by nines and stop when you get a number that the other coefficient, namely 6, goes into. So 9, 18, stop! There you go. See? 18 goes into both. I'm going to turn them both into 18, and it'll make my numbers smaller and easier to deal with. So I'm going to multiply this top equation by 3 because that would turn this 6 into an 18. And I'm going to multiply the bottom equation by -2 uh, because I want a positive 18, a negative, and a positive 18. Okay, so the top equation is going to become 24x minus 18y, which equals 42. The bottom equation will become negative 12x plus 18y, and that'll equal negative 30. And watch this. It's going to come out very pretty here. 24 minus 12 is 12x. 42 minus 30 is 12. X is going to equal 1. Look at how simple that is. It looks like a big ugly problem. It was really not that difficult. It would have become more difficult had I multiplied by 9 and -6, or by 6 and then 8. Not impossible, just a little bit uglier to deal with. Okay, so now I've got to go ahead and find x, oh, excuse me, find y. I think I will use this equation here, and I'll have 8 times 1 minus 6 times y equals 14. And then this is just 8, so I'll subtract 8 from both sides, and I'll get negative 6y equals 6. And this will mean that y will equal -1. And so we'll get the point 1, -1. Another consistent, independent system brought to you by Mr. Lawrence. Okay, last thing we need to talk about, and that'll be the end of the review video. Okay, parallel and perpendicular lines. Parallel and perpendicular lines. Here we go. All right, we've got this equation, 2x minus 3y equals 6. We're going to find the equations of a parallel line and perpendicular. All right. And when we do this, they must pass through the point -6, +2. And notice we're not going to do any graphing. The first thing I'm going to do of this original equation, I'm just going to find the slope. Well, it's in standard form, so that's going to be 2/3. Negative of a over b will be 2/3. There we go. So my parallel slope is going to be 2/3. Now I'm going to use the equation y equals mx plus b. I'm going to plug in my slope. I'm going to plug in x. I'm going to plug in y. I'm going to solve for b. So I'm going to get 2 is equal to 2/3 times -6 over 1 plus b. 2 is going to equal, -4 plus b. b will equal 6. The equation of a line parallel to 2x minus 3y equals 6 is going to be y equals 2/3 x plus 6. Bam! Too easy. Give me a harder problem, Mr. Lawrence, please. You're not challenging me. It's too simple. All right, the perpendicular. Perpendicular. Remember, a perpendicular slope is the negative reciprocal, so I can need -3/2. All right. So I'm going to use y equals mx plus b. I'm going to plug in m, x, and y. So I'm going to get 2 equals -3/2 times -6 over 1 plus b, right? So I'm going to get 2 equals +9. Subtracting 9 from both sides will get me b equals -7. So the perpendicular equation will be y equals -3/2x minus 7. Oh my goodness, it is too simple. All right, that's it for the video. It is a lot. There's two videos together, about 30 minutes total, but you've got plenty of time. We're going to spend time Friday getting ready. And, wow, I went yellow there. Red alert, yellow alert, excuse me. All right, and you've got several days to get ready for it. We're going to take a lot of time on Monday. We've got that whole extra hour we're going to be doing, or excuse me, on Tuesday, taking the test. It's going to be very important to your grade. All right, Mr. Lawrence signing off. Good night, everybody.